actually. So we have a lot to cover today because I kind of fell behind on Tuesday with after going over the announcements. So I'm going to cruise through the announcements pretty quick today. Um, yeah, we'll get started. So by the way, sorry about the recording issue on Tuesday. Long story short, the file converted to a program or a file that I can't actually upload to YouTube. So I don't know what was up with that. But hopefully today's issue that won't be an issue today, and I'll get this one up on YouTube in the off chance that you are watching this on YouTube and not here currently. But that's obviously not any of you right now. So remote learning agenda. What's up? I'm teaching. Yeah, I'm teaching right now. What's up?
Sorry.
Okay. Remote learning agenda, reference it for class pace. We have a log project. I kind of talked about that on Tuesday. It won't be until the end of the semester. A comprehensive review assignment. I was actually just grading these. I was just grading the CRAs right up until we pretty much started class. A lot of you have done them and they look really good. Keep in mind that you can resubmit or edit. If you want to go back and resubmit a full one, you're welcome to do that, and that will be able to boost your grade up. The comprehensive review assignment is like a Mondo quiz, so take advantage of this opportunity to do your best on it. I'm trying to give feedback if you're not getting 100% on it. So take advantage of resubmits to really use this opportunity to boost your grade up. I know that in a lot of classes right now, we aren't, there isn't a lot of opportunity to take assessments and then boost your grade. So think of the CRA as like your ultimate best friend in terms of getting your grade up as best as we can. Also, the projects will be your best friend as we move forward in the semester as well. Cool. So that's due tomorrow. Anytime tomorrow. I'll probably close it realistically on Saturday morning. So you have all the way until that time. Remote learning questionnaires and Ask Me Anything. Continue to do that. Some of you have been emailing me directly. I appreciate it. Also awesome. New ed puzzles and a quizzes was posted today. So here's our remote learning agenda. Quizzes, as you can see, is the homework for lesson number 2, which we're going to begin with probably in like 20 minutes. So that will be your homework for lesson 2. Please be sure to get that done. Participation, not necessarily for correctness. Keep that in mind. I do return correctness, meaning what percentage you got on it, to you in the Google Classroom. But when I input it into Infinite Campus, I give you participation points like any other homework problem. All right, and this is the big one, new this week. Extra Zoom sessions being added on tomorrow. What was previously called office hours, I'll be doing this, and I'll post the link tomorrow. But Zoom sessions tomorrow where we can speak face to face. And yeah, that'll be from 9 to 10 tomorrow. Also, I'm kind of completely separate of this math class. The ASB director, Ms. D, reached out to teachers and asked us if we wanted to be participating in other kind of miscellaneous workshops. Some of the options were like eating healthy and working out and mental health and stuff like that. I decided I wanted to make a little video for eating healthy, so keep an eye out for that. And I'm just going to give some recommendations as to how I try to eat, and just some examples of some of the things I eat. Obviously unrelated to math, but if you want to check that out, keep an eye out for that in the near future. I'm actually hoping to finish it today or tomorrow. So, all right. Okay. Real quick, I got a question. I'm going to address it. So for the homework on the work packet, we don't have, yes, the packets that the work and all of the information, sorry, I jumped to the wrong screen. All of the information for this module, we obviously didn't get text out, so we talked about it on Tuesday, and I said I would throw out the texts on the Google Classroom. Right on, cool. So this is the post that I did on Tuesday, where I put out the student text. It is the one that says student text there. So yeah, since y'all don't have the, I don't know why it's not popping up on my iPad. Hopefully that's not an issue for any of y'all. But since we don't have the actual textbook available, y'all didn't get it, I tried making this available to you in PDF form. So 100%, if you go onto Google Classroom and you see all of this work, all of these options to either take notes and or do work, You could totally do it on a separate sheet of paper. As a matter of fact, some of you have asked this, and I try to answer those via emails, but I would recommend just doing the homework on a separate sheet of paper and then just taking pictures and uploading it. It saves you it saves you ink for your printer. You don't have to print out the actual textbooks. Just do it on a separate sheet of paper. Make sure you do the assigned problems and show all necessary work, but then just take those pictures and upload them to the Google Classroom like you've been doing. That's a great question, and I appreciate all of you who've been asking that. I dropped the ball on Tuesday and not mentioning that. Don't need to do it on the textbook since y'all don't have the textbook. All right, cool. Any other questions before we jump into today's material? If you do, you can unmute yourself and ask, or you can just chat me. Sweet. All right, at any time if you have questions, never hesitate to unmute yourself and let me know. Just kind of holler at me, all right? So today we're going to finish lesson number 1. Actually, this is our screen. Today we're going to finish lesson 1. Whoa. Don't know why it does that to me, but it does. And we're going to do so by starting on page 17. We're going to be looking at finishing up problem number 23, and then we'll move on to page 18. And then after that, as we kind of look over on the right side of the screen as you see it, I know there's 2 today I ams. So we're finishing lesson 1 first, and then we're moving into lesson 2, which talks about degrees in a circle. Effectively, we're going to be transitioning our knowledge of what an angle is to a revolving angle, keeping in mind that an angle just talks about displacement or movement of space, kind of like the hands of a clock. But we know that the hands of a clock don't just stop at 3 o'clock, the 12 and the 3, they rotate. And now we're going to see that today when we view an angle as something above and beyond an acute, obtuse, or right angle or a straight angle, and we'll start to see circular motion and kind of connect our knowledge of angles in that mix. So that's what we're doing today. Quizzes posted, CRA posted, we'll get those done. Sweet. Okay, let's pick up where we left off on Tuesday. And where we left off on Tuesday was on page 20, problem number 23, page 17. I was going to say page 23. So here on page 17, problem number 23, we did all of this work. We realized that in the context of this triangle, we really only knew 3 things from this jump, and that was an angle, which by the way, we're starting to look from the perspective of that being our reference angle, or theta. Theta is our unknown angle symbol. So basically 37 was theta. It's our reference angle. I always try to draw smiley faces there to kind of put ourselves in that angle shoes. We knew one side of the triangle, and we happen to know another angle. So kind of a quick recap, I'm going to zoom through this. We figured out angle A by taking our knowledge from geometry that the interior angles of a triangle, aka all the angles on the inside, are 180, and we subtracted the 2 that we knew, and then we got angle A was equal to 53 degrees. Sweet. And that's how we came about this answer right here, angle A, 53 degrees. Cool. So we knew all the angles of a triangle. What we're working on perfecting in this section through the use of that mnemonic device, SOHCAHTOA, was figuring out every single piece of the triangle. So then we realized, we still have 2 things that we don't know. The hypotenuse, side BA, which is denoted by the variable x, and side CA, which, just for the sake of conversation, I'll just call y, just another variable, something else that can change. So we went about solving for the hypotenuse right over here by using cosine. And we said, from our knowledge of SOHCAHTOA, the one that involves cosine is the one that has a C. C for cosine, C for CAH, and thus cosine was equal to the, let me erase the other 2. Cosine was equal to the adjacent, there's my A right there, boom, over the hypotenuse. Let me kind of make a little space here. The adjacent over the hypotenuse. All of these trig ratios are trig fractions, so it's always going to be some sort of numerator and denominator, where A stood for adjacent and H stood for hypotenuse. And voila, we executed that right there, solved down isolated x, multiplied both sides by x right away to get it out of the denominator, and then divided both sides by that function cosine of 37, which by the way is just a straight up calculator problem at that point. And we used our calculator to get our answer that, okay, the hypotenuse, side x, was equal to 13.77. So long story short is all we have to do now is solve for that side AC, which I called y down here. So what I'm going to do now is I'm going to make a little space here, and hopefully now either you're using a piece of paper or the actual textbook itself now that we have access to this. Again, this is on page 17, problem number 23, and I want to solve for what I called y. So let's talk about this from the perspective of our reference point. Remember, reference means how you view something. Like when you have a referential situation, you're viewing it from one perspective. In the context of this problem, we are viewing it from an angle, a reference angle, theta. So in this case, we were originally given the angle of 37. So I just said, all right, let's just make our reference angle our perspective 37. So in relation, I'm going to get rid of all the unnecessary writing here, okay? In relation to angle 37, what is y? Well, y is across from angle 37, so therefore it's on the opposite side of the triangle. So what we're really doing here to solve for y is the following. To solve for y, side y, we are looking for the opposite side of our reference angle. We're looking for the opposite side of the triangle, the opposite side of our reference angle. So let's kind of use that knowledge, and I'll zoom back up to the problem in 1 second, combined with our knowledge of SOHCAHTOA. Okay. Straight from the start, I can eliminate one of these functions, and that is the cosine, because guess what? Cosine doesn't have an O in it. It has adjacent and hypotenuse, but neither of those things are what we're looking for. So guess what? Cosine, you're out. You're not the function we're going to use to solve for side y. I could use either sine or tangent now, because theoretically, in reference to our triangle, we have both the hypotenuse and we have the adjacent side. I'm going to use TOA though, tangent, and here's why. As I cruise back up to my triangle, in reference to my angle 37, that is my adjacent side, aka next to it, and I'm looking for my opposite. So tangent says, what we can do in a tangent of our angle 37 is set it equal to the opposite side, which is what we're looking for, y, over the adjacent side. And guess what? We know the adjacent side. It's 11. So I can create a function, an equation that will allow me to solve for an unknown by saying, all right, the tangent of our reference angle is the opposite over the adjacent. And now, as I've done this, we have a really easy algebra 1 problem to solve, because all I'm doing is looking to isolate y, and guess what? Y is only having one thing happening to it right now. It's being divided by 11. So how do I get rid of division? Multiplication. So I multiply both sides for that property of equality. Boom, boom. Y is now by itself. Goal is succeeded, and all we got to do is figure out whatever in the world 11 times the tangent of 37 is. So you might be thinking to yourself, I have no idea what tangent 37 is. That makes 2 of us. I don't either. So I'm just going to cruise to my calculator and execute this tan button now that we've seen. So I'm literally going to type it exactly how I had it on the screen. 11 tangent. Notice that's right beneath the FUNC, the function button. You can kind of see towards the bottom left-hand side of the screen, that tan button. So 11 times tan of our angle 37 gives us on the right-hand side of the screen now our answer, which I'm going to round to the nearest tenth, and that's going to be about 8.3. So the opposite side of our reference angle 37, aka side AC, is about 8.3. And notice it, well, ask me to round it to the nearest hundredth. I didn't read the direction. So let's go 8.29, my bad. Just make sure I follow my directions, which by the way, where am I getting this from? Literally at the top right-hand side of our screen, 8.29. All right. That was cruising through pretty quick. I'm gonna leave this up on the screen for 15 seconds, just in case you wanna copy that down. But if you don't and you're pretty comfortable, just kind of hang out for a few more seconds, and then I'm going to move on down to some of the following problems, which will wrap up lesson 1. All right, countdown going on. Cool. All right, cruising on down to the next page, page 18, problem number 28. All right, I'm going to write SOHCAHTOA up here, loud and proud across the top, to remind myself that we have these ratios, we have these fractions, and it's all truly dependent upon what we're given in the triangle to figure out which ratio we're using. Sorry, I was reading a question and trying to talk at the same time. The Desmos calculator is not available in the Google Classroom, but all you have to do to get to the Desmos calculator is go to any web browser, say Chrome, open up a new window, type right in that URL bar, Desmos, would be helpful if I typed it correctly, Desmos calculator, and pick the scientific one. Accessible anywhere, you can get it on your phone. It's actually an app too, so if you're using an iPad, sorry, my brain's kind of obviously messed up right now. If you're using an iPad, a phone, or any other tablet or laptop, you can get the app, or you can find it on any web browser. Great question. All right, back to number 28 on page 18. So let's talk about what we know. We know our reference angle is 37. So theta is 37. Let me write that like this. The angle, we're not looking for it now. Angle 37. What is x in reference to the angle? Well, that's on the opposite side. So x is the opposite. What is 12 in reference to theta? 12 is right next to it. And you might be saying, well, isn't this side, let's call it y, isn't this side next to it too? Yeah, that is next to the angle as well. But y is more accurately another angle, and that is across from the right angle. So that's always going to be the hypotenuse. But what is 12 in this case? 12 is right next to it, and my synonym for next to is adjacent. So basically, long story short here on number 28 is the following. I'm looking for the opposite. I know the adjacent. So which ratio involves an O and an A? Tangent. Okay. So effectively, here's what we know on number 28. The tangent of our angle, 37, is equal to the opposite side, what we don't know, divided by the adjacent side, 12. Now, game on, multiply both sides by 12. Boom, boom. And all we got to do now is figure out what x is equal to, because it's already isolated, by using our calculator and typing in 12 tan 37. So now I'm going to go to my Desmos calculator. And again, I just use Desmos. You don't have to if you don't want to. Every single scientific calculator has sine, cosine, and tangent. So I type in 12, tangent button, 37, and we have my answer, 9.04. Cool. X is approximately, because we rounded it, 9.04, and asked us to round this to the nearest hundredth place. Good to go. Sweet. Okay, one more. This is kind of one of those situations that, like, volume of practice makes it kind of, repetition helps us see the work. So we're going to do one more problem here on page 18, problem number 30. I'm going to keep this a little zoomed out, so in the off chance that you're still working on 28 and trying to digest that information, you have it there in front of you. But here on number 30, what we're given is, again, a reference angle. I'm going to highlight this one in purple. My reference angle is 63. Okay, AKA what that means to me is theta is 63. Sweet. What is known? Well, we know the opposite side. What are we looking for? The hypotenuse. Hypotenuse is across or opposite the right angle, so we know opposite. We're looking for hypotenuse. Which one of our functions deals with opposite and hypotenuse? Sine. Cool. So SOHCAHTOA allows us to realize, all right, we should use the sine function for number 30. And now it's game on. Because the sine of our angle, 63, Sine of theta, 63, is equal to the opposite side over the hypotenuse. There's our sine in SOHCAHTOA. Sine is equal to opposite over hypotenuse. All right. This one's a little bit more difficult because our variable's in the denominator. Don't stress it. We want to get x out of the denominator as we learned back in rational functions conversation. So let's get rid of division via multiplication, always using inverses. Multiplying, sorry about that, both sides by x. See ya, see ya. Now we have a little bit closer problem to being solved, but it's not perfect yet. And the reason why it's not perfect yet is because x isn't isolated. So we think to ourselves, what is happening to x here? It's being multiplied by sine 63. So once again, how do we get rid of multiplication? Repetition all the time, opposite, aka division. And if we divide one side by sine 63, we must do the same on the other. And now x is going to be equal to whatever the calculator tells us that is. So again, I'm going to go back to my Desmos calculator right now, and I'm going to type in that fraction, that ratio, that division problem. 16 divided by sine of 60, not 3, but 63. And it wants us to round to the nearest hundredths once again, so our answer is going to be 17.96. All right. We are almost masters of SOHCAHTOA, hopefully at least. And as always, anytime you have questions, never hesitate to reach out during the session, after the session. If you want specific homework problems solved or more problems done, I'll always be willing to record those and put them up on YouTube. Lord willing, the Zoom allows me to. And also tomorrow from 9 to 10, you know I'm opening up another session. I'd be happy and willing to help us out with that. So in life, any good program always has a good transition or segue. I know some of y'all in BTV knew that very well. So what we're going to do is use the last few problems here in lesson 1 to segue us into lesson 2. So the last thing that we need to do is not solve for sides, but solve for angles. Solve for how things are displacing or moving in a angular way. So the last application of SOHCAHTOA, of the basic trig functions, is to do exactly what you see being highlighted right now, not solve for a side, but solve for an angle. So what we're going to do here is I'm actually going to move on down to problem number 35 on page 20, and this is where we're going to wrap up lesson 1. Problem 35, page 20, here we go. So we are given a right triangle. Some of you Pythagorean theorem masters could probably figure out what the side here is going to be by doing this. That's great, but guess what? We don't care about what that is. They didn't ask us for side CB, which I denoted as X there. They asked us to solve for angle A, which is theta. So let's talk about from the angle reference, from the point of view of the angle. Here we are, shrunken down, sides of angle, what we know and what we don't know. Okay, well, we happen to know that this side right here is next to angle A. I mean, so is 9 technically, but 9 has a better classification because 9 is across from the right angle. So really, the side 9 is the hypotenuse, and the side 6 is the one that's next to it, which we know is synonymous for adjacent, okay? So we know the hypotenuse and we know the adjacent side. So in reference to our angle, we can probably use one of our 3 main ratios. By probably, I mean definitely. Which one involves an adjacent, an A, and a hypotenuse, an H? It involves the H, but doesn't involve the A, sines out. It involves the A, but doesn't involve the H, tangents out. You might have been thinking, that's great. That was redundant, Mr. Benham. You could have just realized that cosine is the one because it involves the A, the adjacent, and the H, the hypotenuse. Cool. So cosine of an angle is equal to the adjacent side over the hypotenuse side. Game on, because guess what? We happen to know what the adjacent side is, and the adjacent side is 6. Sorry, I'm kind of trying to keep this color coordinated as best as I can. So that's why that color palette keeps popping up. And the hypotenuse side we know is 9. So unlike the first few problems that we did on Tuesday and to start class off today, we are not given a value of theta here. We're looking to solve for it. But the beautiful thing about solving for an unknown angle is it's still just straight up calculator work, because we can kind of view this from a traditional algebra perspective. And what I mean by that is, looking at this cosine theta, to me, it kind of looks like cosine is being multiplied by theta, or rather theta is being multiplied by cosine. Again, the reason I can say that is because we see no operation sign differentiating or stuck in the middle between the two. So theoretically, what that means to me is that if I want to get rid of this cosine, all I got to do is divide by cosine. Now, the problem is if we try dividing by cosine on a calculator, we're going to run into some serious issues. So I'm going to actually venture out and say that division of cosine, when you divide by cosine, just like, let's say we divide by 2, that is truly the same thing as multiplying by the seconds reciprocal, okay? So 10 divided by 2 is truly the same thing as 10 times 1/2, the reciprocal of 2. Same thing can be thought of here. If I want to divide by cosine, I could think of that similarly, and let me change the color here, as multiplying by 1 over cosine. Multiplying by 1 over cosine, which now comes in our knowledge of exponents. Technically speaking, this cosine has a power of 1 and a power of 1, so multiplying by 1 over cosine is synonymous to multiplying by cosine to the negative 1. Long story short, what we have just done is we have created the possibility through what the book and many mathematicians call inverse trig functions, opposite trig functions, which will allow us to use a calculator. Because when I multiply cosine to the negative 1, which is synonymous to 1 over cosine, which is synonymous to dividing by cosine, and that was a lot of words there. That's gone, leaving us with just theta. What we're looking for is now isolated. That's good. Now, what I'm going to do on the right side here is I'm going to actually rewrite this just by using the commutative property, throwing that 1 over cosine in front. But keep in mind, 1 over cosine is the same thing as cosine to the negative 1. And I'm going to take cosine to the negative 1 over 6/9. So all we have to do now is basically, as I copy and paste here, use a calculator. Now I have theta isolated like it's any old variable, and now I can use a calculator to help us solve. Here we go. So I'm going to move here to my function part of the Desmos calculator. Again, what I just did here, y'all, is I went from the main portion where it's underlined in main, and I moved across like we were working with when we were talking about logarithms and e base values. I moved to the function portion, and notice, what do you see here? Oh, look at that. That's a cosine to the negative 1. And then I'm going to type in the fraction that I had there, which was 6/9, aka 6 divided by 9. And what that inverse function, that cosine negative 1, allowed me to do is that it allowed me to now use a calculator to solve for my angle. And what's my angle down there? 48.189. So back to my final problem. It says, all right, let's figure out that angle to the nearest degree. Well, our answer was 48.189, but we want to go to the nearest degree, so we round that to just 48 degrees. All right, long story short is the following. Anytime we're trying to solve for a side, we use regular trig functions, sine, cosine, tangent. Anytime we're trying to solve for an angle, we're always using that inverse function, which is that tangent, sine, and cosine to the negative 1 power. All right, so we have about 10 minutes left here in class. I'm going to, again, take this a little bit longer today than previous classes because we have a kind of a lot to cover. But before I move forward, does anyone have any specific questions? All right. Degrees in a circle, lesson 2, page 29. All right. So again, I mentioned that segue thing where we move from one topic to the next. On that last example, we were solving for a specific unknown angle. And now for the next few lessons, specifically here in 2 and 3, we're going to be viewing angles in a variety of ways. Angles, as I mentioned earlier, like the hands of a clock, can move beyond the standard, rigid, acute, right, obtuse, and straight angles to actually moving into 360-degree rotations, and a 360 is just a circular movement. So what we're going to do here on page 29 is we're going to go through kind of a little bit of a long process in creating what we'll soon come to know over the course of the rest of this year as our beloved unit circle. Now, I want to level with you that the unit circle is going to look super intimidating. I'm not looking for pure memorization of it, but rather how it's created. So, unit circle. First thing, we have a circle, and if it's a circle, it means it made a full rotation, which means it went from a starting point of 0 degrees all the way around to 360 degrees. If any of you have ever had the ability to jump up and make a full rotation, you all know that's a 360. So it kind of follows right in line with our knowledge of that. So question number 1, it says, all right, locate the point where 180 would land. Well, 180 is just half of 360. So it's just halfway around the circle. Therefore, number 1 says, all right, 180 has got to be halfway around the circle. Every single one of these, by the way, can just be turned into a fraction. The degrees that we're looking for over the total degrees. And if you were to work with a ratio of 180 divided by 360, you could 100% simplify that down by taking out the common factor of 180 and getting, 1/2. Right on. Cool. Number 1, done. That's the easiest one of this page. So then we're saying, all right, number 2, locate the points that start at 0, where here's where it starts at 0. And then we want to go up by 90 degrees. So we all know what 90-degree angles are. 90 degrees are right angles. So there's 4 right angles here. There's this one. There's that one. Probably you're getting the idea. There's this one. And last but not least, that one. There's actually perpendicular lines here, 4 90-degree angles. But they want us to label the 90-degree intervals. So really, the first 90 degrees would be from here to there, which would make this a 90-degree angle. And think about it like such, 90 is just half of 180. So if this was the whole 180 degrees, well, then naturally 90 would only be, not the full thing, but only half of it. That kind of quarter of the circle. So actually, if you think about it in another way, 90 over 360, what we're looking for over whole, simplified down is 1/4. All right, so that's a fourth of the pizza right there. Right on. Guess what? We already did the second 90-degree rotation because 90 plus 90 is 180. Sweet. 90 plus 180 is our third angle, 270. There's 3/4 of the circle, and then when we go 90, we're back to our full rotation of 360. So what we've done here on page 29 is we have succeeded in doing problems numbers 1 and 2. We're starting to create the angular motion of a circle. Now, I do want to say before we move on to number 3 that it's going to start to get more complicated. Notice that we have 3, 6, 9, 12 more lines there, which are 12 more angles. The whole point of this is just to realize that angles can extend above and beyond and create rotations, which we see a lot in the natural world around us. It just may not be visible in our daily lives on an outwardly obvious level. All right, I digress. Let's get back to the task at hand, which is number 3. We want to locate the points that start at 0 and go up by 45. All right, well, we're always starting at 0. And we're going to go up to 45 degrees. I don't have a protractor on hand, so I'm going to use some basic math. And I realize if I'm trying to find 45, well, 45 is just half of the way to 90. So I'm just going to cruise up halfway to 90. Boom. Okay, there it is. So here's my 45-degree angle. Cool. I go another 45, I get to 90. So then I go another 45 degrees. 90 plus 45 is 135. I'm just doing some basic quick addition here right now. That's how I'm getting these numbers. Then I go 45 more degrees. Gets me to 180. Then I go 45 more degrees. Just seeing repetitions of 45, and that's 180. 180 plus 45. This 45-degree rotation gets me to 225. Again. 270 plus 45 gets me to 315. And as we finish off, 315 plus 45, this final little piece does get us back to 360. Okay, unit circle starting to truly take shape, starting to truly take form. It's just repetitions of major angles. Now, in previous math classes, specifically in geometry, not geometry class, it sounds weird. you've seen what they call special right triangles, and those special right triangles often come in the form of 30, 60, 90, and 45, 45, 90. And that's actually what we're seeing manifest here today. 90 degrees, 45 degrees, which is actually going to take us to our final thing here, which are going to be 30-degree angles. Because it says there are 8 points left, and here's the 8 points that they're talking about in part 4. 1, 2, 3, 4, 5, 6, 7, 8. 8 lines left, 8 angles left, and we want to start these by, it doesn't give us this information, but it's really 30-degree increments. So we start at 0, we go up 30 degrees. 0 plus 30 is 30. We go 30 more degrees. What's 30 plus 30? 60. What's 60 plus 30? 90. Already got it. What's 90 plus 30? 120. What's 120 plus 30 more? 150. All right. 150 plus 30, 180. 180 plus 30 is a 210-degree angle, getting closer to a 3/4 rotation. 210 plus 30, 240. 240 plus 30, you get the idea. Finishing off here, 270 plus 30, 30 more degrees is 300. By the way, that just means that this angle right here, that's just a straight up 30-degree slice. 30 more degrees, this angle here, gets us to 330. And then 30 more degrees, this angle right here, there's 30 more degrees right there in a rotation, gets us back to our starting point of 360. All that we just did there, y'all, is we just made continual repetitions of 30-degree angles. We kept adding little pieces of 30 every single time to create our beloved angular unit circle here. That is where we're going to leave off for today. So tomorrow, we didn't get through all of the original plans. Notice we only got through what on this screen is numbers 1 through 4. I have a lot more that I still wanted to talk about in lesson 2, which we'll really formally pick up on Tuesday. But I would love to encourage all of you to come in for tomorrow. It may be an hour, it may be a little bit less, and then we can kind of go over specific homework problems and a little bit more supplementary information on these first 2 lessons. So hopefully I see you all tomorrow. If not, I hope you have a great weekend, and I will see you on Tuesday at the latest. Never hesitate to ask me questions, either now or in the future. And if you don't have any, I'll see you all on Tuesday or tomorrow. Okay? So if you don't have any questions, feel free to sign on off, and I'll see you then. Bye, y'all.
Bye, Mr. Dunham.
Bye. Thank you for coming.
Thanks.